Hi everyone, this video is going to cover polynomials with what their factors are and their zeros. The Algebra 2 book also throws in the word linear, but it's section 5.2 in Algebra 2. But mostly what we're going to cover is something we call roots, or sometimes we call them zeros, or we call them the x-intercepts. Or there's other names now, I'm drawing a blank. These are all where your graph crosses the x-axis. Okay, so these are roots, these zeros, and this section calls them zeros a lot, are just wherever your graph crosses the x-axis. So if we're looking at a polynomial is just like a name for y equals, or the long part of the function, like this one's one of the problems I'm going to do here in a minute. So this is a polynomial before the equal sign with 1, 2, 3 terms, and that was what section 5.1 kind of went over. So polynomials, mostly we're doing a lot of x to the third power ones, and we could have x to the fourth or x squared or different things like that. So let's remind ourselves of that zero product rule. And zero product rule, I'm going to look at something that's already factored. So we're going to look at the zero product rule. And so this is already factored. And the zero product rule tells us if we factor something, we can find those zeros. See how it said equal to 0? Those x-intercepts, because that's where y is 0, or the roots, whatever they want to call them, is we set each factor equal to 0 and solve. And you'll do this a lot, I think, the next section as well. So we're going to add the 2 over, and this one's 2. And you could see if this was 0, to make 0 here, if this was 2, 2 minus 2 is 0. So we end up with 2 giving us 0 here. 0 times anything is 0. The other solution, you'd minus the 1, and then you'd have 2x equals negative 1. Divide by 2, and x is equal to negative 1/2. And those are our two solutions. And that's the zero product rule. And we can see if we put negative 1/2 in here, negative 1/2 times 2 is negative 1. Negative 1 plus 1 is 0. 0 times anything is 0. So we're looking at where each factor makes a 0. And let's look at one that gets a little harder that we have to factor. X to the third minus 2x squared minus 15x equals 0. So this one is a little bit harder here, but we have x on each term, and so that means we could pull an x out of those terms. So I'm going to go ahead and do that. So I'll take the x out and write it in front, and I'll subtract 1 off each exponent so that the first one becomes x squared. So there were 3. I took away 1 and wrote it in front. Now there are 2. Bring down that minus, bring over the 2. There were 2, and I'm going to take out 1, leaving 1. And I took out the only one here, so all I have left is that 15 equals 0. So I pulled 1x out of each spot. Then I can look at factoring this part here. So I'm going to look at that negative 15. That's our in number. What combinations of negative 15 would add or subtract a negative 2? And this method only works when there's not a number here in front of x squared. So if I just look at like 5 times 3 make 15, and those would subtract or add to 2. So we're good. We'll go with these two. And if the 5 was negative, excuse me, my nose is running. If the 5 were negative, then negative 5 times 3 is negative 15. And negative 5 plus 3 would give us the negative 2 here in the middle. So we can factor that middle into x minus 5, x plus 3. And this is the factoring. We brush it because you should have seen it introduced the last couple years in your math courses. So then now we have 3 factors. 1, 2, 3. Even though this doesn't have a number, it's kind of like x plus 0 factor in a parenthesis. So we're going to set that one equal to 0. So anytime you pull an x out, one of your answers is 0. The next one is x minus 5 equals 0. The last one is x plus 3 equals 0. So because we had an x to the third, we have 1, 2, 3 answers. The one before only had 2 answers, so it was an x squared. So this one will be add the 5 over, get 5, subtract the 3 over, and we get 3. So those are our 3 solutions there. So what if so here's the one thing it's also talking about is graphing these. I was trying to look at my notes, I'm sorry. So we know it crosses the x-axis at these 3 spots. So if you're trying to find like what does the graph look like in between, I'm going to graph it on my calculator. You can actually make a chart and pick numbers between each spot where it is hitting that x-axis at 0 to try to see what the graph looks like if you're doing it by hand. So I'm going to type this in real quick. X to the third minus 2x squared minus 15x. I type this into my graphing calculator under y equals here, and then I don't have a glare. Aha! I'm not in my classroom. I'm at home today, and it doesn't glare my calculator. Yay! So we can double check. Does it cross at? We have 0. Yeah, and then we got -3 and 5. So here's our 5. Here's our -3. So our answers are right. Now, if you kind of want to see what it looks like, you have to plug in these numbers in between each of those zeros to see what the graph looks like. And that's just something that they kind of emphasize in the homework, is finding more points of the graph. Or you can use technology as well. It's fine too. What if I wanted to graph something like y equals x minus 1, oops, already in a parenthesis, x plus 2. So a lot of people get confused when they see it this way and then they're told to graph it. You can still plug that in your calculator and graph it, or you can do it by hand. I want to do it by hand. I think it's really important that you know both methods. And we'll check our answer on the calculator. So I always do an H chart, x, y, and then my formula is x minus 1, x plus 2. And let's put in something like 0, because that's always a pretty number. So we'd put in the 0 in both places, so I'd have 0 minus 1, 0 plus 2. 0 minus 1 is -1, -1, 0 plus 2 is 2, so 2 times -1 is -2. Pretty easy. You find the two solutions, times them. Let's put in another number, maybe 2. So 2 minus 1 and 2 plus 2. 2 minus 1 is 1, and 2 plus 2 is 4, so 1 times 4 is 4. And let's do one in the negative, maybe -3. I don't know why I picked the numbers that I just did, but that's okay. -3 minus 1, -3 plus 2, oh, I do know why I did. So this is -4 and -1. Negative times negative is a positive, so we get +4. This is actually, anyway, well, here's our graph. Let's graph this. I don't have a ruler with me today. That's okay. 0, -2 is here. 0, -2. 2, 4. 1, 2, 3, 4. 2, 4. And -3. 1, 2, 3. -3, 4. 1, 2, 3, 4. It goes up like that, and you could see the graph from here. We don't know exactly where the vertex is, but I just did one at 0, one below and above, but there's our graph. So you can graph them still by hand. Let's put this in the calculator. I'm going to clear off what we saw before, and I'll put the parentheses on this calculator are here. If you're using one on the line, then you just use the parentheses on the 9 and 0 on the keyboard. So x plus 2, graph that sucker. Ta-da! There you go. Get the same kind of graph that we got. So either way, this is by hand, this one's on the calculator. What if I am given kind of the opposite of, what if I'm given that the that I have a cubic polynomial in standard form from with the zeros -2, 2, and 3. I'm going to add in what is. Okay, so what is the, oops, smearing stuff. What is a cubic polynomial? Cubic means x to the third in standard form with these zeros here. So we're going to work backward. We already know the zeros. We're not looking for the zeros. So what I can do is put them in like a factored form, knowing that. Okay, so first of all, I don't know why I can't think today. I should pause, have a cup of coffee. We're going to use that zero product rule and kind of work backwards. So we know f of x or y. You could have used y, and we would, or 0, but we want it in function form, so I put the f of x in. We know using this first one, we would have to have the opposite sign, which is x plus 2, because the root is a minus. Remember, those are the opposite of each other. And then the next one would be x minus 2, because again, this is positive, opposite, and the last one would be x minus 3. So we're kind of working backward. We set them equal to 0 and solved, and it gave us that negative answer. Now we're going to take that answer and revert it back to the opposite sign, or the positive or opposite sign of whatever it was, so that we then have this cubic polynomial. It's not in standard form, so if you're not asked for standard form, you're done. This is it. This is the answer right here. Unfortunately, it tells you to put it in standard form, which means you got to multiply it out. So I'm going to start by multiplying the first two with FOIL. So x times x is x squared. X times -2 is -2x. -2 times x is positive 2x. Positive 2 times -2 is -4. And then we still have to times this by the other term there. So now we can see that these make 0, so I'm just going to cross them out because they added to 0, which is super helpful. Makes the problem actually way easier. Now I'm going to take each term left, which is only the x squared and the -4, and times them by each term here. Now if I would have had 3 terms, I would have had to take this one times both of these, then the next one times both of these, and then the next one times both of these. So you might have 6 different terms when you're done. This one will have a little less just because those added to 0 in the middle. We just got lucky. So x squared times x is x to the third. X squared times -3 is -3x squared. Now I'm going to switch to the -4. -4 times x, -4x. -4 times -3 is a positive 12. And then I look for any common terms that I can reduce, and I don't have any. X to the third and x number. We don't have anything we can add together. So that's actually our answer. So the hardest part of this is being careful when you multiply it out. So you put it back. Don't make those ones hard. Unless you were never good at multiplying, then they might be a little harder. Then it talks about multiplicity. So let me give you an example of that. But what if I have y equals x plus 1 to the third power? Okay, so x plus 1 to the third power. So this is, when we see something like this, we know if we're looking for the zeros or those x-intercepts, we know this is the same as having 3 of these. So what is the answer when I set them each equal to 0 to find those zeros? Is -1, -1, -1. But we would have seen it 3 times. So the answer is -1 with a multiplicity of 3. All you're saying is this -1 is the answer 3 times. So watch out for that word multiplicity. It just means your answers are repeating themselves, and you have to be able to know when your factors are the same. Obviously, then you have a higher multiplicity. Okay, then let's look at relative. I keep blowing my nose. Minimum and maximum. Okay, so relative minimum and maximum. if I have a graph, maybe it looks like this. I don't know, I'm making it up. So maybe it looks something like this. Hold on just a sec. Okay, sorry, my nose just kept running, so I finally just paused it. Okay, so if we were looking at a graph like this, here's our x, here's our y, and this would be considered a relative maximum because it's a relative, meaning it's only between these two that it's a maximum. So it's a maximum point at that spot, and then this would be a relative minimum and another relative maximum. So that's the highest, lowest kind of thing. And you're asked to find those. Probably the easiest way is on a graphing calculator. So either online and you use a little trace to go up to that point, or you can do the calculator. Let's see. Let's use one. I don't have a problem. I didn't write one down like that I had pre-made. So let's try. If I do like 5x to the third power minus 3x plus, I don't know, 10. Let's see what that looks like. See if it has a relative max and minimum. It does, except I can't see anything. So let's go back and make this a 1 real quick. Maybe I'll be able to see it better. There we go. Still kind of, it's small, but anyway, that'll work. So it goes up and then it goes down and back. So I have a relative maximum and minimum there, and I am actually going to change my window to go from -5, 5 to -5, 5, and what that's going to do is allow me to kind of zoom in, and I can see those relatives a little easier. And then the way that I find that, I hit secondhand calculate, and I'm going to go to maximum, and I want to find the maximum there. And notice it's saying left bound, so I have to move this to the left bound of what I want it to find the maximum of. So it's blinking on the left, then I hit enter, and then I have to move it to the right side of what I'm looking for and hit enter. I still never have understood this guess because it's not even anywhere near, ever. There's our answer. So that point is -0.44, whatever, y is this. And it will ask for decimals. Some of them will be pretty, but a lot of these kind of answers are going to be decimals. So pay attention to after you put it in Math Excel right below where you click it in on how many decimal places they want you to go out. So if I wanted to do the other point, which is a minimum, I again go to calculate, hit minimum. I'm already on the left side, so I just hit enter. And then I move my little arrow with my button over here to the right side. I don't care about the guess, so hit enter. And so it ends up taking 3 enters to get to 0.44.1, so it's almost the same thing. On the other side, a little off on the negatives, but there you go. There's your minimum and maximum, and those again are called the relative minimum and the relative maximum, because you can see there's points up higher on the graph and there are points lower, but those ones are the relative. So that kind of should help you with some of the section 5.2. Good luck.